Hello, everyone. This is Douglas Moore. Today, I will be talking about how to make your data visualizations portable and scalable. Portability is important because, imagine that you have a data viz on, say, on your laptop in Jupyter, and you need to, and you're doing fine. You're creating your analytics, sending it off to your customers and your boss and your teammates, and you're doing fine there. But then, the world changes. Let's say the company needs to move their data infrastructure, analytics infrastructure to the cloud. You need to go on vacation. You need a backup. You need to automate this somehow, and just run it as an overnight job. You need to scale up your visualizations, not from, one or two or 10 or 20, to, thousands, tens of thousands of visualizations. You need to store those visualizations along with your data and your analytics for access via an application. You need to store this for audit purposes or approval purposes to prove that your model is valid. So these are all important reasons why you need to portable data visualizations. However, portability is hard. Every platform has nuances. They're basic assumptions with 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 your setup with Jupyter Notebook. It's local to the compute, the Python, and your CPU, and your data is local to your Jupyter Notebook. And so some of the packages have taken advantage of these assumptions to help scale up the interactivity across a large data set. But moving to the cloud or another shared platform, uh, those assumptions are broken. Security is very important. There's certain security, lack security between your browser accessing local data because that's a trusted environment. But as you move in the cloud, a lot of these packages are going to try to access data outside the browser, and that's going to get blocked. With CORS uh, header and CSRF type things. There's also a difference in bandwidth between the compute and the display. There's, again, you're probably dealing with much more data. And so all these assumptions have changed. And this in part, because a lot of the packages have been built and designed based on certain assumptions. So a lot of these change as you move to cloud or another platform, and so that presents a challenge. So we're going to talk about strategies about how to deal with that. But before we get into that, let's talk about the Python data visualization landscape. This graphic is produced by Jake Vanderplas. He's also the creator of this Altair package, a declarative package, which is based on Vega Lite, which is simplification of Vega, but also based on D3.js, very popular JavaScript, very powerful, kind of lower level JavaScript library. And then there's a whole family of visuals based on JavaScript, like Plotly and Bokeh are quite popular. Bokeh itself is, kind of a backend, if you will, to HoloView. It's a very higher level, makes difficult tasks simple kind of package. It references Matplotlib, which is universal. Bokeh, Data Shader. Data Shader is one of these libraries that allows you to draw, visuals of billions of points because it has a couple of things going on. It has a very fast parallel processing with Dask and the recovers. It also implements a number of visual summarization algorithms, I like to call them. So these, but again, you end up with images rather than say interactivity there. Again, it's a trade-off. When you move to a browser at the end of a VPN, you're gonna have to give up some of your interactivity and your bandwidth to do that. So, and then there's a number of packages. One I started out my career with is OpenGL. So that's a fun thing. But so, there's a lot of libraries. James Bednar, he put together this blog, 3-part blog, Why So Many Libraries? And, he's proposing or put forth this pyviz.org. They're promoting unification. The backends, Pandas is near universal in terms of data science, analytics, and Python. And Pandas has a plot backend, and default there for many years is Matplotlib. But with that work going on now, you can see your backend drawn with Bokeh or hollow views, and with hollow views, that should imply that you can have a data shader backend. So again, lots of changing, if you will, in the data visualization landscape. So let's talk about some strategies here. So I'm going to walk you through my demo notebook, which I'll share later. So the first one is I call Hope, Magic, and Hence. Again, you have your standard. Sorry, I seem to have lost my pointer. I have seriously lost my pointer. Okay, here we go. The so standard matplotlib, plot.show, you expect to show up, but again, things are a little different. So, well, with Databricks, you have to do display. This will, with no arguments, will go out and look for that figure object and display it here in the notebook. Different notebooks can have different utilities. I think in Zeppelin and z.show, and, Jupyter, it's display, so on and so forth. Now there's Matplotlib inline. There's Matplotlib to draw it inside the notebook. This tightly binds it to the IPython object. So we have that here, increase compatibility. Now, the next major strategy I want to talk about is, render as an image. Almost every package will support rendering as an image. Sometimes that's simpler. Sometimes that can get quite involved. We'll see that in a little bit. And the first one is render to an in-memory buffer. I like these because you don't have to, name your temp file, and you don't have to delete it when you're done. So here we do it. We save the figure as a temp file. We give it a format. Now, if we want to actually view it again, you should always close your plots. But if we want to view it again, we can get those bits from that buffer, base64 encoded, use UTF-8, embed that into a little bit of HTML. Now we have an inline image, and then we can use the workhorse. Every package, every notebook has, you say, some form of display HTML here. Boom. And you can see along the way that HTML, we added a title. All right, great. So we can render for some packages to an IO buffer, but sometimes graphics packages, and I found some in that landscape, that don't support bytes IO or string IO. So what do you do next? You have to save it as a file. Sometimes you need to plot that and store it for audit purposes, or you want to embed it in Markdown or HTML. So in here we go, there's this tracking API for ML machine learning experiments called MLflow, very popular these days, open source package. So in here, imagine this code was for doing your training and other experiments. Now you want to say, you create some artifacts to prove the worth of your training. And so now you just save that. And you save it to a real file path, because that's what MLflow is going to need here when you log that artifact. MLflow is going to log the file path as a key to it, and then going to take the contents of the image and log that. And now you can get to this ML flow and the tracking that it's been doing just by clicking on that link in the notebook. You can see all the metadata associated with your experiments and artifacts. And here's our plot here that we logged into the tracking API. So that's pretty cool to be able to track all your experiments and log all the artifacts. And then again, that goes to reproducibility, auditability. And sometimes you want that image and you want to embed it with other, you know, text and other media, if you will, to describe it. So this is an example of embedding it inside of Markdown. You can embed it in HTML and so on and so forth. So I'm just going to delete that. All right, next strategy I want to talk about is all this JavaScript, you know, packages on the left there that created HTML, JavaScript, and inline JSON. I want to talk about those for a while. So a couple of those, Bokeh and Plotly, we'll go through. So with Bokeh, you know, we're creating some sample data, some random time series here. We just, you know, with the right package installed, pandas greater than 0.25 and Bokeh, pandas Bokeh, we just set the back end there. Again, there's always some kind of flag or whatnot. Now, this will force this to render, and when we do this, it'll create a Bokeh object here. But now, to display within this notebook system, we need HTML. So we use file HTML and the CDN objects for all the resources to, you know, all the JavaScript are there, and we call display HTML, and now we have this here. So we went from pandas to data visualization, 95,000 points. Now the reason we can get to 95,000 points there is because Bokeh, along with Plotly, will embed the data in a binary form. Other packages like Altair and some others, when they embed the data, they embed it as JSON, which is much less compact. So here's an example with Plotly, and you can see with this notebook vendor, Databricks, they now have native support for Plotly. You just do ts.plot, and boom, you have your visual here. So again, as long as you set the backend on pandas, you're good to go. Okay, so now let's say you're doing animations, and animations like Matplotlib, that works closely with the event loop in Jupyter Hub, which is very close to the Python and the compute there. We don't have that luxury in a notebook that's in a web browser. We're the data center where the Python is running is in Virginia. I'm in Boston, so that's not going to quite work here. So what we do is we do Matplotlib. We build up our animation here. So this is our animation object, and now we just convert that to HTML, and then we display that in the browser, and we have this animation. Now this is nice. You can embed it in web apps. You know, any of these techniques that generate HTML, you can embed it in a web app, in iframe. You know, if you want to dress up your animation, oh sorry, your plot with additional HTML, you can do that. Now, since this is a Spark and AI conference, we should talk about data, lots of data, and Spark. So imagine that you have your whole data lake and you want to analyze it, and Spark's a great tool to look at your entire data lake and look at structured, unstructured, binary data, so on and so forth, and use a lot of Spark workers and Spark SQL or PySpark or something to filter the data that you want to look at, and then summarize the data, take aggregates, and then you know, to complete this pipeline, you have to bring all that data, that summary data, the smaller data. You can't bring your entire data lake, but you can bring the summarized and filtered data into your driver, and then you have to run that through your data visualization package at ultimately, if you're going to render in a browser, it has to produce HTML, JavaScript, so on and so forth. Boom. So you have a huge amount of data reduction here, in a way larger than what you have on your laptop, especially here. But on the back end, your data lake is much larger than your laptop, much faster than that. So, the main strategy here is reduce your data lake to a manageable number of data points that your users can actually visualize and interact with and filter early and often. Again, you don't want to bring back too much and overload your driver, overload your browser. So here we go again with Bokeh, doing this stuff. We're doing the setup. So the thing is, this pandas data frame, we're going to fill it with data from Spark and workers. We're going to have 10 partitions in this. We're going to create some random numbers, and we're going to display that, and we get that here. So that's from the previous run. Let's see, we're going to start this up. Probably not even going to use that cluster. Anyway, so that's how you go from your data lake through Spark, your driver, to a pandas data frame, which with this 2 pandas to your visual. So that's how you connect all the dots, pun intended. All right, now, I don't know about you, but I'm getting tired of looking at this file HTML, CDN, display HTML. I just want to look like it does and work like it does, a lot simpler. So to do that, install a custom hook. A lot of packages have the ability to hook the back end, if you will, and customize it or just redo it. So we're going to do that with Bokeh. This is our show doc hook. We're going to take the Bokeh object, and we're going to do what we've always been doing, right? But we're going to install this hook, these callbacks, like this. Now, the only one I've gotten to work thus far is the show doc. I don't know what the load does. The show app is for interactive apps, which aren't supported yet. We haven't figured that out. So we have this. Again, you do normal setting. You'd see something like this in Zeppelin. And then you just render it. You do a TS plot. Again, pandas and what's going on there, that unification of that. You can switch out the backend by specifying the backend that you want. Here we go with our time series. So that's it for that series. Now we're going to go on to Altair. Now, Altair is pretty tricky here. So again, we're going to render this as a PNG. Actually, we're going to skip PNG and SVG and go straight to PDF. But you have to install Chrome, as a web browser on your driver node in the data center in Virginia. So you do it with this. There's a new package, Altair Saver, which helps things out. Of course, restart your Python context. Again, Altair protects you from rendering too much inline data. Default limit is 5,000 rows. So if you want to exceed that, you have to set max rows to some number. I know my data set uses about 50,000 points. And then I want to say, verify the data format. So we have PDF and SVG, PNG, and so on and so forth. So we skip over those two, and we're going to save as a PDF. Again, with save chart target, it looks at the target, the file extension there, sees that's PDF, saves it to this location in the file store. So boom, we have that. Now that's available through display HTML. We'll give a reference to it. And now we can download this. Of course, on the back end, we can automate that and email it off to someone. And there's our chart. Nice thing with PDFs is it's very, very reproducible. So All right, and then the next one, which we don't have time for in this series, is rendering via driver proxy. With a driver proxy, you know how I think I was saying that Altair, it can do out of band data access. It can go directly to your laptop and access CSVs or JSON. Well, to support that in a web environment, a secure web environment, you need to create a proxy that runs on the same compute, has access to that data. You save the data, and then you go through, you let the Altair JavaScript go through that proxy, and that proxy will help you securely get access to that, and that proxy will help deal with all the headers, the CORS headers, and the CSRF type headers and whatnot. So but you know, we don't have enough time for that, so that'll be saved perhaps for a blog post or something. Now let me talk about Spark and generating plots within Spark executors. So to do that, first we're going to take the strategy of creating a user-defined functions. Now you might do this, say, you know, to process trillions of data points spread out across sensor logs that you have in your data lake. So this function, again, this is for demo, but we're you know, our decaying sine function here, parameters A and B. And we're going to create a plot of that. And so now we have a function to get the plot. We're going to create a function to take that plot or that figure and convert it to an image. And we return this here. Now Spark now understands the image data type inside of a data frame. It looks like a structure like this. So now that we have that full end-to-end from data to figure to image, again, it's a headless rendering strategy. We're gonna, and we have that wrapped up in this function called getPlot. GetPlot here in the image schema. We're gonna create a user-defined function, a Spark user-defined function. We're gonna use that in Spark SQL as shown here. This is my unit test, kind of like the test code and stuff. So we do that, pass a couple parameters, 4 and 5, and 500 points. We have our decaying sine function here. Again, that was a Spark job that ran. Now we're ready. We can generate, you know, 10, 100,000, million of these with different functions. Again, this is synthetic, but this could run over all your source data, all your sensor logs, if you will, and create individual plots and store it as images. So now we have images inside of a data frame. We have data fields that we've projected from that metadata, and that's going to be important. So now with these plots in the data frame, of course, with Spark, you know, unified API there, you can save that data. You can save it to Parquet, you can save it to Delta gives you transactions. So you save this, and now you can go back and record it. You can optimize the Delta table. You don't have, like, you know, millions, billions of small image files in cloud storage, which would, you know, be slow to store and retrieve. But here, you know, we can retrieve that based on metadata associated with the image, or join it with contextual data to retrieve just the images that we want, you know, to perform our audit function or an analysis, or other engineers could come and look up what our computational modeling did. So this is how you kind of scale that plotting out horizontally. Again, it's all based on the headless technique. So in summary, you know, I've provided a number of portable data visualization strategies, all the way from creating an image buffer and then manipulating that to an image file, you know, for strategies for working with HTML and JS type packages, like Plotly and Boca, and being able to render that across multiple notebook platforms. And then also, you know, because this is the Spark and AI Summit, we have to talk about the data lake and how to address all that data of your enterprise and how to visualize that. Uh, the hooks, creating your own hooks to make porting so much easier and cleaner, all the way to headless Chrome browser. Back in the day, there is a headless X Windows server, and still one of these packages requires a headless X Windows strategy too. In the future, we'll get into discussing how to establish an API proxy and enable Altair and other packages like that. And then we shared how to scale out with Spark, scale out horizontally to do those graphics, those visualizations needed across, not 10 or 20 data sets or time series, but tens of thousands, hundreds of thousands of time series, like some of our customers have done. So in the next slide, I'm showing the resources. We have my GitHub account. The slides will be posted there. I'll cross-post there here. They'll be available from the organizer of this and my demo notebook, so you can run through this. And I'm listing the references here for your reading pleasure. So thank you, and climb on.